Hello, class. So, physical geography, class number 6. So, you're going to need this page, right? It says class 5, physical geo 6. And then you're also going to need your reading because I want you to follow along. We're going to be looking at some basic things about the globe. So, when you're looking at maps and you're looking at globes, there's things you need to be able to see on them, right? Your globe here. The things you need to be able to see and recognize and be able to figure out. It's kind of like this big line right here. What is that? And then what's this line right here? And then why are there vertical and horizontal lines all over the place? And what do they do? And what do they show? And why does it say 45 degrees here? And why does it say 15 degrees in here? Or 15 degrees east here? Or west? Or west, not west. Or 30 degrees. What does it mean? You know, why on a globe? Or, for example, see here. Why on the map of the United States does it have those vertical and horizontal lines? So, for instance, like right there, those lines. Why does it have that? Or going over to, see if our world map. Yep, our world map has it too. Why does it have those vertical and horizontal lines? Or even the dotted lines? Or what does Tropic of Cancer mean? Or Tropic of Capricorn mean? Or that little thing right here. And there's, hey Jim. Or what do all those lines mean? Uh-oh. What do they mean and why do we have them? So we're going to do some basic map reading skills, globe reading skills. We want to be able to figure out what they mean, their significance, why do we have them, and what do we use them for? So let's open, let's do this. We're going to go through some of this, and then you are going to have a little bit of work to do. It's not complicated. It's not hard. But you do need to go ahead and pull this out so we can look at it and we'll get started. So let's start with right here where it says the Earth's form. All right. So Isaac, you ready? Go ahead and start. Oh, wait. You're not here. Oh, okay. It says the Earth's form. It says, it is he that has sitteth upon the circle of the earth, that stretcheth out the heavens as a curtain, and spreadeth them out as a tent to dwell in. That's out of Isaiah 40:22. It says the earth is a spheroid, or more accurately described as a pear-shaped ellipsoid. So it's not an actual exact sphere. Columbus described the shape of the earth as a pear in his later years. Satellite photographs have enabled scientists to see the earth rotating in spin with its stem to the north. When he established the heavens, wisdom, was there. So who is wisdom? That would be God. Where am I? Oh, when he inscribed a circle on the face of the deep, when he made firm the skies above, when the springs of the deep became fixed, when he set for the sea its boundary, so that the waters should not transgress his command, when he marked out the foundations of the earth, then I was beside him as a master workman. That's out of Proverbs 8:27-30. Seen from the space, the earth is exquisitely beautiful and appears as a blue ocean sphere that is marked with areas of green and brown, the continents, and white areas of ice, the poles. The heavens declare the glory of God, and the firmament showeth his handiwork. I love that verse. It's Psalm 19:1. Out of whose womb came the ice, and the hoary frost of heaven? Who hath gathered it, or gendered it? The waters are hid as with stone, and the face of the deep is frozen. It's Job 38:29. So, all right, let's look at the earth's dimensions. Its diameter. Hopefully all of you know what diameter is, but just in case, we'll go over it. A circle or a sphere, a diameter, circle or sphere, and a diameter is the distance from one side that goes to the other, and it has to pass through the midpoint. So that's the diameter. 7,927 miles at the equator, but only 7,900 miles at the poles. So That's why it says the Earth is not exactly a sphere. So it's more like, is that right? Uh-oh, I did it wrong. It's more like, it's a little bit fatter than it is taller. So the poles are at the top and bottom, and then the equator is a line that is halfway between the poles. It's an imaginary line. All right, the circumference, or the distance around the circle, is slightly shorter when going from top to bottom than the sides. The surface, 197,751,000 square miles. Solid cubic miles, 260, that is 100,000 billion miles. The Earth's surface measurement. So let's really tune in right now. It says geographical circles are imaginary circles encircling the Earth, which are used to determine position on the globe. So let's look at something right here. Let's see where it says, gotta hold this higher. Ow! See where it says 45. See that blue line? That blue line goes all the way around. It's not an actual blue line. It's an imaginary one that we use for separating the Earth and for navigation. So it says, imaginary encircling the Earth, which are used to determine positions on the globe. Great circles, let's see, let's keep going. So right now, to catch up, here's the globe, right? We see circles that go around. Now we're gonna go right here. It says great circles. Great circles divide the Earth into two equal parts. Number one, the equator. The equator is an imaginary circle around the Earth, equally distant at all points from both the North Pole and the South Pole. So, equator, this guy right here, the big blue one, right? Equal distance from the North and to the South Poles. It says it divides the Earth's surface into Northern Hemisphere and Southern Hemisphere. And then it goes on to say a meridian is an imaginary line of the Earth that passes through geographic poles and any given point on the Earth's surface. Geographic longitude is computed from 0 degrees to 180 degrees, east and west of the prime meridian at Greenwich, England. So why do you say Greenwich, England? Is because that's where they started. So if you look on a map, there's a line that cuts the Earth in half. Cuts the Earth in half vertically. Where'd you go? And you're right here. So there's a line that goes down and then up the other side of the Earth, right? And it cuts it in half like this. So, and the reason it goes through England is because England was the major shipping power at the time, and they came up with it. So they decided we're going to do this one right here. And we'll get more into that later. All right. So, and it computed from 0 degrees to 180 degrees east and west of the prime meridian in Greenwich, England. Now, more small circles. A small circle is any circle that divides the Earth into two unequal parts. The parallels are small circles of latitude that pass through the Earth parallel to the equator and are used for determining geographical position. So now we're right here, we're at the top. Latitude is the distance of a geographic position from the equator. There are 90 degrees north latitude and 90 degrees south latitude. All right, so latitude is this. So here's your equator. When you start going up, these are measurements of latitude. So you go up a number of degrees, and it goes from 0, and the North Pole is 90. There are 90 degrees north latitude and 90 degrees south latitude. So you could say 90 degrees north, or you can say 90 degrees south. And all of this has to do with finding location. And you can get very, very specific. So all of this came into about when we didn't have GPS, right? GPS tells us where to go, how to get there. Well, this was the old school fashioned way of doing things. Well, and they still do it now. But we just use GPS. But places like the military or in shipping, they still use it because that's how we use it. It also says the length of the degree is 61 1/6 miles or 1/3600th part of the circumference of the circle. Let's keep going. So on our little globe, you've got the North Pole and South Pole. This is a really good picture of it. You've got the North Pole circle, then you've got the Tropic of Cancer, then you've got the equator, then the Tropic of Capricorn, and the South Pole circle. It says climatic circles are four imaginary circles called the tropics, which are parallel to the equator and serve not only to determine position but mark important climatic boundaries. The tropics, situated 23.5 degrees from the equator, mark the highest latitude which receive the vertical rays of the sun. So, it's talking about direct light from the sun, right? Because direct light is different from angled light in intensity and thus causing different amounts of heat and different amounts of light, and it just makes things different. Says the tropics, situated 23.5 degrees from the equator, mark the highest latitude which receives vertical rays of sun. Distance from the equator determines the angle at which the sun's rays hit the earth. This plays an important role in temperature. The heat of the vertical ray is much hotter than the acute ray. Therefore, it is hotter at the equator, which receives the sun's vertical rays, than it is in the polar regions, which receives the sun's acute angled rays. So again, we got the Earth here, sun over here. This is going to receive vertical rays, while this is going to receive acute or angled rays. And these Tropic of Cancer, when you go from the equator to, where are you, Tropic of Cancer? Okay, right here. When you go from the equator to the Tropic of Cancer, this zone or area receives vertical rays, which makes it much hotter. So thus you've got all of this area that's much hotter than things that are north of that. And we also get more various seasons. And then the Tropic of Capricorn, same idea, but south of the equator. And that's why places like, for instance, Venezuela, where my wife lives, they don't have seasons. They have a dry season and then a rainy season. But in terms of temperature variation, there's almost none. And the further you go from the equator, the more variation of temperature is, until you get to the very ends, where the poles, where it begins to get not so much variation because it just stays cold all the time. But you still get some. But in those tropic areas, remember, Tropic of Cancer goes north, Tropic of Capricorn goes south. In that area, there's not a whole lot of variation of temperature unless you change altitude. So if you go up very high, then you'll get into colder areas. But at sea level, it's very similar because they receive direct light from the sun. All right, so we're going to go to C. Therefore, it's hotter at the equator, which receives the sun's vertical rays, than at the polar regions, which receive the sun's acute angle rays. All right, now let's go down here to Tropic of Cancer. Is the imaginary climatic circle located 23.5 degrees latitude north of the equator on June 21st, which is called the summer solstice. The sun passes over every point on the northern tropic, creating the summer seasons by increasing the temperatures. At the same time, the Earth's southern hemisphere is experiencing less heat in their winter season. As the Earth rotates on its tilted axis, the lines of latitude hit by the sun's vertical rays differ from day to day. Between June 21st and December 22nd, the winter solstice, the rays of the sun move more southward. So again, these regions have to do with how the sun hits the Earth. Tropic of Capricorn, basically the opposite, was talking about in the southern hemisphere. The imaginary climatic circle, 23.5 degrees latitude south of the equator. So let me show this to you. Where is this? I want to make sure we're really clear. Here's our globe. Here's the North Pole. That's the South Pole. Here's our equator. Here's our Tropic of Cancer line. Tropic of Capricorn. And then our lines of latitude. Our lines of latitude go from 0 degrees up to 90 degrees. North, because we're going north. Same thing works going down. Zero degrees, 90 degrees south. So when we say 90 degrees north, we know we're going north. When we say 25 degrees north, we know that wherever we're talking about, we're going north. And when we say 55 degrees south, we know that we're going south. So in a second, we'll get into lines of longitude, which which will allow us to pinpoint exact places on the Earth. Let's see. The polar circles, Arctic and Antarctic, are situated 23.5 degrees from the geographic poles and mark the limits of illumination when the sun is vertical at the tropics. Each is located 90 degrees distance from the tropic opposite of the equator. So then there's another one. Let's say polar, why am I going blank on this? Polar circles. So this is your so up here would be your Arctic polar circle, and down here would be your Antarctic polar circle. All right, so you have each side, and it works amazingly well. It's amazing how exact it is throughout the year, and that's due to the Lord's creation of how He designed things. All right, so now we look at the world's time zones. They begin at the prime meridian. I'm actually going to skip part of this. I'll have you go back and read this. So section C, I want you to read, and then we get into the Earth's poles. So again, you have the North Pole and the South Pole. Again, I'm going to leave this for you to read. But these are lines of latitude going that way. The meridians are lines of longitude, which go north-south. And what happens is you have places where they intersect. So and the lines of longitude, as we said, go from 0 degrees to 180 degrees. And so what I can actually do is I can say, for example, so let's say here's England right here. Right? And the prime meridian let's say that's 0 degrees east and west. If I go this way and if I want to find somewhere, and I say, okay, it's 25 degrees north, 17 degrees east. So that means it's 25 degrees north of the equator, and then 17 degrees west of the prime meridian. So by using these numbers, we can pinpoint exact locations of countries, of things that happen, especially prior to GPS and satellites. This was how you navigated. If you wanted to find something, you would have to put it in at with degrees, with latitude and longitude. And it can actually get even more detailed because each degree is broken up into minutes. So you can say 3 degrees, 6 minutes, and it's the very exact location. And you can find, and that's what we have used, and that's how they were used to find places, to find people. If people were in distress, they would call in and say, "This is my location." They still use it in the military and in shipping. But here's what you need to do. Here's your paper, right? You need to go through our reading, and I want you to define the words right here. Let's see, what does it say? Yes, it says, watch Physical Geography, video 6, and read along in the handout, then follow directions. So I want you to go through and define these terms that were mentioned on this page. And that's it. So again, it's basic things, but it's things that we really need to understand as we look into physical geography. So that's it. This is a bit longer today, but there's not a lot of difficult work on this part. So make sure you go through, reread, go find those key terms that you understand it. And we'll get more into this stuff later on. But I wanted to start to introduce it to you. So if you're kind of confused about it and you're not sure, it's okay. We'll keep going with it. But other than that, hope you have a good afternoon, and bye-bye.